Hello and welcome back. This is Dan, and we are continuing our function transformations video. In this lesson, we will be learning about hyperbolic functions and how to transform them. So we'll look over the form first, which is normally h of x equals a divided by the quantity of x plus p, and then all plus q. And our comparison equation, or our baseline equation, will be h of x equals 1 over x. So we'll check to see how altering a, p, and q transforms our function. But first, this is what our baseline equation or baseline function looks like. Now, what is the effect of q? Q, just like how it functioned in our linear and quadratic function, is going to be responsible for a vertical shift. So when q is positive, our graph is going to shift upwards, and when our q is negative, it's going to shift downwards. So we can take a look here. In the first part on the left side, we can see we have a -2 for our q. So our graph shifts downward by 2 units. And on the right side, we have a +2. So our graph is going to shift upwards by 2 units. And this is exactly what q does. It just shifts it up or down depending on whether it's positive or negative. What about a? If our a is greater than 0, then the graph is going to lie on the first and the third quadrants. If our a is greater than 1, the graph will be further away from our comparison equation of h of x equals 1 over x. And for a between 0 and 1, as a goes closer towards 0, it's going to move closer to the axis in comparison to our h of x equals 1 over x. So this is kind of what that looks like. The red solid line is our baseline equation, and we can see when our a is greater than 1, which is our blue, it moves further away from the axes. You can see this goes outward there. And when our a is between 0 and 1, it goes closer towards the origin. And you can see that with our green dotted line. Now, what happens when a is negative? So this will make sure that our graph lies on the second and fourth quadrants. And when a is less than -1, it's going to be further away from the axes in comparison to our baseline equation for this, which would be h of x equals -1 over x. And when a is between 0 and -1, as it tends towards 0, the graph will move closer to the axes in comparison to our baseline of h of x equals -1 over x. So this is what this looks like here. So again, our baseline equation is going to be represented with the red solid line, and you can see when our a is more negative with the blue lines, it moves further away, and when our a gets closer to 0, it goes closer towards the origin. And so that is our effect of a. Now what about p? P is going to be responsible for our horizontal shift, so this will move us left and right. And when our p is positive, it'll move to the left by p units. When our p is negative, it'll move to the right by p units. So we can take a look over here, and we see that in our first equation, we have h of x equals 1 over x plus 2. So this should move us to the left by 2 units because our p is positive. And as you can see, this moved to the left 2 units, and on the right, we have x minus 2 on our denominator. So this is going to move to the right by 2 units, and that's exactly what it did. So now let's go over some questions together. Transform the baseline function down 2 units. So our baseline is h of x equals 1 over x. And if you remember, to transfer down, we need to use our q. And if we want to go down 2 units, this will be -2. So what we're going to have is h of x equals 1 over x minus 2. And this is our answer. Now let's try another one. Transform the baseline function to the right by 5 units. So here our baseline again is h of x equals 1 over x, and now we want to go to the right 5 units. So since we're going left or right, this would be our p. And if you remember, if we need to move to the right, we are going to subtract 5. So we're going to have h of x equals 1 over x minus 5. And this is our answer for this question. And let's do one more together. Transform the baseline function so that it is in the opposite quadrants and further away from the baseline. So if you remember, what does this is our a. And if we want it to be in the opposite quadrants, we're going to have to put a negative a. And then if we want it to be further away from the baseline, it's going to have to be, our absolute value is have to be greater than 1. So our baseline function is h of x equals 1 over x. And we are going to transform this, so it's going to become h of x equals negative, and remember, a just has to be anything greater than 1. So we're just going to use a 2. So we're going to say negative 2 times 1 over x. And this would be our answer. Now, this negative 2 can be any negative number as long as it's more negative than negative 1. So it can be negative 3 times this, negative 4 times this, anything like that. That'll all work. So if you guys have any questions, please let us know in the Ask a Tutor function or ask us in our live lessons. And if not, well, I will see you guys next time. Bye.